Hello student, good morning. I am Dr.A.K. Today I am going to discuss density and molecular mass of gaseous substance. Last class I have discussed ideal gas equation. I derived the ideal gas equation and also I derived combined gas law. Now I am going to discuss density and molecular mass of a gaseous substance, how both are related, density and molecular mass. It is very easy to correlate. Ideal gas equation, we know ideal gas equation can be rearranged as N upon V is equal to P upon RT. We know that PV is equal to nRT. This is the ideal gas equation. PV is equal to nRT, small n RT. Small n is the number of moles. Then PV is equal to nRT, then n is equal to what? Easily we can calculate. And n by V also we can know. PV is equal to nRT. Then n upon V means what? N upon V easily we can just by rearrangement we can know N upon V is equal to P upon RT. This is from ideal gas equation. Here you know N is equal to number of moles, V is equal to volume, P is equal to pressure, R is equal to universal gas constant, T is equal to absolute temperature. Then here N upon V, this is important. Then N upon V, now in the place of N, number of mole, what we will write? A small m divided by capital M, because N is equal to m upon a small m divided by capital M, means mass divided by molecular mass. Then mass divided by molecular mass is called mole. 1 mole. Then number of mole is equal to mass of the gas divided by molecular mass of the gas. Then this n value if we will put in the this relation, above relation what I told you, n upon V divided by P upon RT, then n upon V. In this n is equal to a small m divided by capital M, we will put, then we will get relation, that is a small m divided by capital M into V. After the putting the value of a small n, a small m divided by capital M into V is equal to P upon RT. Then now here you are getting relation between M and other P upon RT. Then here our intention is to know the relation between density and molecular mass. Then now M has come, and also now M upon V is there. After putting the value of N, now you are getting a small m divided by mv, molecular mass into volume. Then this m upon v, that is equal to d, density, d is equal to m upon v. Then now you can write, for the m by v you can write d, then d upon m is equal to p upon rt. Then see how you got the relation density and molecular mass. Then d upon m is equal to p upon rt, where d is the density. And now you will rearrange this, means d upon m equal to p upon rt. Then you can get the value of, after Rearranging, you will get M is equal to D into RT divided by P. This is the relation between density and molar mass or molecular weight. Correct? Molar mass, molecular weight. Also you can tell. Then this is the relation between M and D, means molecular mass and density. M is equal to dRT divided by P. This is very important relation. Now I am going to discuss about the Dalton's law of partial pressure. This is also important, very important concept because many numericals are asked on this concept, on Dalton's law of partial pressure. What is this? Try to understand. The law was formulated by John Dalton in 1801. It states that the total pressure exerted by the mixture of non-reactive gases is equal to the sum of the partial pressure of individual gases. Suppose you have taken 2-3 gases, 4 gases mixture, but they should not react, it should be non-reactive among themselves. Then what is the, you can say, total pressure? Then total pressure is the sum of the pressure due to individual gases. The total pressure exerted by the mixture of non-reactive gases is equal to the sum of the partial pressure of individual gases. This is called Dalton's law of partial pressure. Here also you can tell in a simple way the pressures which these gases would exert if they were enclosed separately in the same volume and under the same condition of temperature in a mixture of gases. The pressure exerted by the individual gas is called partial pressure. Partial pressure means pressure due to individual gases, and that all pressure you add, then is called total pressure. Then total pressure P total is equal to P1 plus P2 plus P3 plus P4 plus P5 like that at constant temperature. Then total pressure is equal to, you can say, sum of individual pressure. Total P, suppose P is the total pressure, capital P, then P total is equal to P1 plus P2 plus P3 plus P4 like that, where this P1, P2, P3, P4 is the individual pressure of the gases. Okay. Now again, just to understand one more concept, because this when you are talking about the partial pressure or pressure, then you should know about the aqueous tension. What is actually aqueous tension? That also you should understand. Gases are generally collected over water and therefore are moist. It will be wet. Then pressure of dry gas. Suppose you want to know the pressure of the dry gas, but in that dry gas some moisture will be there. Then pressure due to the moisture. What is the pressure due to the moisture? You will deduct from the total pressure, then you will get pressure due to the dry gas. Okay, this is related to that. Gases are generally collected over water and therefore are moist. Pressure of dry gas can be calculated by subtracting vapor pressure of water from the total pressure of the moist gas, which contains water vapors also. Parts pressure exerted by the saturated water vapor pressure exerted by saturated water vapor is called aqueous tension. Aqueous tension of water at different temperature. Now I am telling some examples that how much pressure will be there due to the water. Then here, as for example, when temperature is 273, then pressure in the term of bar will be 000. Okay, and when temperature is 283, 10 degree more, then the aqueous tension will be 0.0121. Now see, when temperature became less, means 283, 273 it was 000. Now it was not 00, but it is less only, 0.0060. Now when temperature decreased 283, then now it became more, 0.0121. Now again at a different temperature, means 288, then its value was 0.0168. Like that way, 291, at 291 its value was 0.0204. Like that way, this pressure is due to called aqueous tension. Aqueous tension, that is, this is due to the water vapor present in dry gas. Dry gas means generally whatever will take pressure, in that water vapor will be present. Then that also creates pressure. Then that, if you will pressure due to this water vapor, if you will remove, will deduct, will subtract, then you will get the pressure due to the dry gas. Okay, pressure due to the dry gas, and this pressure due to the saturated water vapor is called aqueous tension. Now actually this directly you can know that if you want to know the partial pressure, value of partial pressure in terms of mole fraction, partial pressure in terms of mole fraction, then direct formula is there, you can understand. Okay, as for example, now directly I am telling you that how you can say partial pressure and mole fractions are related. Partial pressure and mole fraction, how they are related, just I am telling you that partial you can say pressure, partial pressure is equal to mole fraction into total pressure. This is the relation. This is the relation, final relation, that partial pressure of any gas, of any individual gas, is equal to mole fraction of that gas into total pressure, into total pressure. This is the final relation. But if you are interested to know how this value has come, then I am giving you hint now. Okay, because this concept, hint, what I am giving you now, concept that is useful any time you can use when you are solving the numericals. Then now finally I have told you that partial pressure of any gas in the mixture is equal to mole fraction of that gas into total pressure. This is the final. But how this value has come, now I am giving you hint. Also I can tell derivation. Just you listen carefully and then you will understand. Okay, then its a starting point is its starting point is ideal gas equation. Okay, its starting point is ideal gas equation. We know that PV is equal to nRT. Then now this PV is equal to P is the pressure. Then now we can think this same thing can be applied for the individual gas also. Then for the individual gas you can write, suppose it is a mixture of three gases, P1, P2, P3, P4 like that. Then same formula you can use for the individual gas P1. Then PV is equal to nRT. Then suppose for individual gas you are utilizing, then P1 is equal to N1 RT upon V. N1 means now this N1 is for number of molecules of that gas. Number of moles of that gas which you are considering. Then P1 is equal to N1 RT upon V. Correct? This is the for the first gas. For the first gas, same way for the second gas you can write P2 is equal to N2 RT upon V. RT upon V because they are kept in the same container. Hence V will be the same. R will be the same. Temperature is also the same. Then only P and N will change. Pressure and number of moles will change. Then for the first gas, P1 is equal to N1 RT upon V. And for the second gas, P2 is equal to N2 R2 upon V. And for the third gas, P3 is equal to N3 R2 upon V. Means three equation you can tell for the three gases. If fourths are there, fourth also you can write in the same way. After that, second step I am telling you, then total pressure, what will be the total pressure? Then P1 plus P2 plus 3, that is equal to total pressure. Then this is the second step. And if you put the value of P1 plus P2 plus P3, then everywhere you will find only N1 will differ. N1 will differ, N2 will differ, N3 will differ. RT upon V will be common in all. Then RT upon V you keep it outside. Then in bracket you will get N1 plus N2 plus N3. Then this N1 plus N2 plus N3, that value only will be in the bracket outside RT upon V. Then this EF means you can tell this is the total number of moles become total number of moles, that is the N1 plus N2 plus N3. Okay. Then this is second step I have told you. Third step, what you have to do, that you take three equations you have taken for P1, for P2 and for P3, anyone you can take. As for example, you take P1. P1 is equal to, you have written N1 RT upon V. Then just to divide it by total pressure. Divide it by total pressure, both side. P1 is equal to N1 RT upon V. This is first for the first gas you have written. Then now you divide both side by total pressure. Total pressure means P1 upon total pressure divided by total pressure. P1 upon total pressure. Then what you will get? That if you will write the value, for gas equation, P is equal to that PV is equal to nRT, and then P is equal to nRT upon V. Means now P1 upon P total. Then now P total equation you will write, then all things will be cancelled out. And what means P1 upon P total, that if you will write the value and you will solve it, then RTV all will cancel out. And what will remain? Then N1 divided by N1 plus N2 plus N3. Only this will remain. Then this is actually this N1 divided by N1 plus N2 plus N3. That is called mole fraction. Mole fraction. This is the third step. mole fraction x1 you can tell. For the gas 1, x1. Then now you can see you got P1 upon P total is equal to x1. Means you got N1 divided by N1 plus N2 plus N3. Then N1 plus N2 plus N3, for that you write only N, a small n. Then N1 upon N, that is actually mole fraction x1. Then this you got for first gas. Like that way you can get for the second gas. P2 upon P total, that is equal to x2. Then for the third gas, P3 divided by P total, that is equal to x3. Then see, like that way we will get x1, x2, x3, x4 like that. That is the mole fraction of that gas. Correct? Then this you got these things at P1 upon P total is equal to mole fraction you are getting. X1 is called mole fraction of the first gas, x2 mole fraction of the second gas, x3 mole fraction of the third gas. Okay, like that way. And thus a general equation. What will be the general equation? Already I told you in the beginning, fourth step. That is this P is equal to, because you already got the relation P1 divided by P total is equal to x1. Then what is the P1? Cross multiplication you do. P1 divided by P total is equal to x1. Then P1 is equal to what? x1 into P total. What I told in the beginning. Then this is the P1 is equal to, means partial pressure is equal to mole fraction into total pressure. Correct? That I have given hint, or you can tell you have, this is the derivation. You have understood? I think so. It is very easy. Concept is very easy. Now today I am stopping only here. Again next class we will meet. Thank you.